Now, you may think, come on, dude, like no one would accept that. No one would accept the risk and continue. And you're probably right. Most users wouldn't knowingly click accept the risk and proceed. So the only realistic ways that the man in the middle could bypass this warning. I bring this up because in cybersecurity, you may learn things that don't seem so exciting or maybe not relevant to ethical hacking. And I want you to see that there are going to be some wax on, wax off exercises that you may not realize you just learned how to fight. And this time, notice that we are presented with a warning, and we just got a new one. It says, software is preventing Firefox from safely connecting to the site. So let's clear this out. Let's try going back to wikipedia.org, okay? And you can already see we've been redirected to the hit song. What's up, Code Crew? In this video, we are going to be diving into the wonderful world of proxies to monitor and modify web traffic while still maintaining a secure connection. We're going to take a high-level view on how the browser interacts with the web server certificate and public key to create that secure connection. Then we're going to step things up a notch by introducing a proxy in the middle to monitor all of the encrypted web traffic and see how the browser responds. Finally, once we've convinced the browser to trust our man-in-the-middle proxy, we will then redirect all of the web traffic to Rick Astley's hit song, Never Gonna Give You Up. So let's go ahead and dive in. Now, if this is your first time here, it may seem like I'm going off the rails a bit, but I promise you everything's going to come together in the end, so just stick with me, okay? So here's you, and you want to go to Wikipedia. So your web browser will start what's known as a TLS handshake with the web server. This is the process that must occur in order for secure communication to happen between the client and the web server. So in turn, Wikipedia's web server will respond back with a certificate and public key that basically says, you can trust me. And the browser will then check the certificate up against a list of certificate authorities, or CAs. This is the list of organizations that the browser or your computer trust to issue valid certificates. So if everything checks out, the browser will say, okay, this looks good to me. Here is a session key, which is encrypted with the web server's public key so that we can start our secure communication. And from that point, the GET request is processed and all other subsequent communication is going to happen over that secure encrypted channel. Now, if the browser doesn't trust a certificate from Wikipedia's web server, it will display a warning message for you that says, hey, the certificate looks suspicious or it looks unverified. Are you sure you want to proceed with a secure communication with this server? Now, you might wonder, why would this happen? Well, imagine that there's a man in the middle, someone who intercepts Wikipedia's legitimate certificate and public key, and instead of forwarding it along to you, they instead send their own fraudulent certificate and public key in order to get the browser to encrypt sensitive information intended only for Wikipedia to be sent directly to them instead. Now, if you choose to ignore these warnings and proceed, your browser will then derive a session key from the man-in-the-middle's public key. This means all information you share will be encrypted for the attacker instead of the legitimate web server. The attacker can then intercept, read, modify the data while forwarding the traffic with the legitimate session key to keep the whole connection seemingly normal. Now, you may think, come on, dude, like no one would accept that. No one would accept the risk and continue. And you're probably right. Most users wouldn't knowingly click accept the risk and proceed. So the only realistic ways that the man in the middle could bypass this warning and go unnoticed is if they have already exploited you or your machine by either social engineering or maybe some malware that's going to secretly install their certificate into the client's certificate authorities list, right? But to think that this attack just happens is overlooking many earlier stages where you could have taken steps to protect yourself. Now, if you're looking at this and you're like, man, that's like so devious, right? That's so smart. Let me point out to you that this is the same process that's used in legitimate organizations when they're trying to monitor their employees' web activity, right? So let's say this is Bob, and Bob's supposed to be working on his TPS reports, but instead he goes to Wikipedia. His browser will start a TLS handshake with the organization's proxy. The proxy will start its own TLS handshake with Wikipedia's web server. Wikipedia's web server will send back a certificate and public key. The proxy will intercept it and send its own certificate and public key. Now, at this point, Bob's browser will not trust the proxy certificate and let Bob know that his online activity is probably being monitored, right? So to avoid this, the organization will install the certificate to Bob's browser, basically making the connection seem normal, but in fact, all traffic is being intercepted and monitored by the proxy. Now, notice that this process, again, was the same process that we saw when we were looking at our attacker example, right? The only difference in these two was the intent and the consent, right? Bob probably signed some like waiver when he got hired that his online activity would be monitored. So he agreed to it. And the organization's intent was simply to protect their workplace from bad actors and increase employee productivity, right? So I bring this up because in cybersecurity, you may learn things that don't seem so exciting or maybe not relevant to ethical hacking. And I want you to see that there are going to be some wax on, wax off exercises that you may not realize you just learned how to fight or even defend yourself. So I just wanted to bring that to light for you, okay? So now that we understand how these proxies work, we're going to have some fun with it, right? We're going to redirect all web requests to Rick Astley's hit song, Never Gonna Give You Up. So let's go ahead and dive in. You're gonna wanna pop open a Linux machine. Here I have a fresh Ubuntu that I'm gonna load up real quick. You're gonna make sure that you have internet access. Go to settings, go to your network. Make sure you have one adapter set to NAT, okay? Let's go ahead and turn those machines on. Okay, so once you're logged in, go ahead and pop open a terminal with Control-Alt-T. You're gonna run mitmproxy, and more than likely, you're going to see a message that says it can be installed with apt install mitmproxy. So let's go ahead and run that sudo apt install mitmproxy. Just say yes, let that run. Okay, once that's done, you can type in mitm and then tab on your keyboard, and you'll see that we have 3 tools that have been installed. We have man-in-the-middle dump, man-in-the-middle proxy, and man-in-the-middle web, okay? Just wanted to bring that to your attention. So let's just do the most basic example before we start doing the Rickrolling, right? Let's just use the proxy to monitor requests and responses on the web. So here we have this really basic script. You're gonna just copy this. It's going to simply log request URLs and print out responses, okay? So let's copy that, and you're gonna type in nano basic proxy.py. Paste that in, save it, and we're going to run it with an mitm dump -s basic proxy.py. And you can see now we have a proxy server listening on port 8080. So go ahead and pop open a web browser. And let's just try to go to Wikipedia, right? Just like in our example. Now notice our proxy isn't doing anything. That's because we have to adjust the system's network settings to pass all web traffic through there. So come over to the system tray on the top right. You'll probably see somewhere you can adjust settings, and you'll notice by default your network proxy is off. So just click that settings icon, set it to manual, and we're gonna set for both HTTP and HTTPS traffic localhost, which is 127.0.0.1. All right, and you can see already in the background, you can see some traffic coming through the proxy, right? But just to be safe, right, we'll also do it for HTTPS 127.0.0.1, port 8080, and we can close that. All right, so now all of our web traffic is flowing through this proxy. Let's try going to a different website now, okay? So let's try going to, let's say, Facebook. And this time, notice that we are presented with a warning. And we just got a new one. It says, software is preventing Firefox from safely connecting to the site. This issue is caused by mitm proxy, which is either software on your computer or your network. And if you come over into advanced, you're gonna see that you can view the certificate. And if you're a little bit unsure still of what the certificate does, it tells you very simply right here, websites prove their identity via certificates which are issued by certificate authorities. So we can click view certificate. You can see that this certificate for Facebook is actually being issued by mitm proxy. About as suspicious as it can be, right? So what we can do to fix this is over in the browser settings, you can come down here. We'll click on settings, and you can get there a couple ways. You can go to privacy and security, and you can scroll down, and there's like 2/3 of the way you'll find view certificates. You can also type it in here in the search bar, view certificates. Now notice in this list of certificates on file that identify certificate authorities, there is no man in the middle in this list, right? It's in alphabetical order, right? You can see there's a microsec, Microsoft. There's no man in the middle proxy, right? So we have to go to import, come to home, right click, and make sure to show hidden files. Now, we'll scroll up to the top a bit, and you'll see this .mitm proxy folder. Go inside of there, and there is the certificate. So you'll click select on that. You're gonna be presented with a message that says, do you trust mitm proxy for the following purposes? And we have an option to trust the certificate authority to identify websites. So we'll click on that, okay? All right. And you can view it if you'd like, right? But here you can see that it is now in the list of certificate authorities. So we'll click OK on that, and let's go back to Wikipedia, okay? So let's come to wikipedia.org, and notice that we do not have a warning message. It just loads, no problem, right? Let's try going to x.com. And again, no problems, right? The page loads just fine. And you can see on our proxy server, all the traffic, the requests, and the responses coming through in clear text, right? Now, if you want to see more on the traffic, you just simply adjust this script here, okay? You would just print some different values for the response object, right? So now that we have a solid understanding of how the proxy behaves, here we have another script that's going to be used for our Rickrolling. Of course, we define the Rickroll URL, and I have some excluded domains to avoid infinite redirection, right? So these are all the different domains that are associated with a YouTube page. And I also have a list of domains that will keep track of which URLs have been used to Rickroll so that it only does it one time. So it'll just redirect it one time, and then the second time they go to that same website, it'll just load as normal, okay? So let's copy all this, come into our terminal, we'll Control-C to end that, and we'll nano rickroll proxy.py. Paste that in, save it, go ahead and run it with the same command, mitmdump-s rickroll proxy.py. And it's running now. It's running. Now we're going to start seeing something cool, right? So let's clear this out. Let's try going back to wikipedia.org, okay? And you can already see we've been redirected to the hit song. I'm not going to play it for copyright purposes, right? But you see the idea. So let's try going back to Wikipedia again. So let's see if our proxy behaves as it is intended. And this time it loads like normal. And then let's go back to Facebook, and boom, we got redirected again. So let's go to Facebook for a second time. Oh my gosh, it's so cheesy. And this time it loads like normal. Now, when you've had your fun and you got your laugh, come back to your proxy. We're gonna do some cleanup now. We'll just Control-C to stop that. Come over into your settings, simply disable your proxy, and everything will be back to normal. And with that, guys, I hope you had a wonderful time. I hope you see how easy this can be once you have a solid understanding of the concepts. And don't forget to tell all your friends, smash that like button, hit subscribe, and I will see you next time. Bye-bye.